Okay, what we want to learn how to do here is to change decimals to fractions. And before we do that, I think it's important to review the kinds of decimals that will convert into fractions. It turns out not all decimals will convert into fractions, but two kinds of decimals that will are the kinds of decimals you get when you change fractions to decimals, and we can go back the other way. So let's see what those two kinds are. So let's look at a fraction like 3/8, and if I do the division, take 3 divided by 8, and put a decimal and some zeros there, and remember to put the decimal straight up in the answer. Let's do this division. So 8 into 3, can't do it. 8 into 30, well, 4 times 8 is 32, that's too big, so let's use a 3. 3 times 8 is 24, subtract. 6 and 4 is 10, carry the 1 to the bottom. Here's 3 from 3 is 0. 6 is smaller than 8, okay? So that's good. Bring down the 0. 8 into 60. Well, 7 times 8 is 56. And if I subtract, I have a 4 here. 6 and 4 is 10. Carry the 1 to the bottom. It works, okay? 4 is less than 8. That works. Bring down the 0. 8 into 40. 5 times 8 is 40. And it goes evenly, okay? This is what's called a terminating decimal. The decimal number equivalent to 3/8 ends. We get a 0 remainder, and that so the division terminates. Let's try this one. How do you convert it to a decimal? You do the division. So let's take 3 and divide it by 11. So put a decimal and some zeros, and put the decimal up here. How many times does 11 go into 30? Well, 11 times 3 is 33. That's too big, so better use a 2. 2 times 11 is 22. 8 and 2 is 10. Carry the 1 to the bottom. And notice the 8 is smaller than 11. So we did that one right. Bring down the 0. 7 times 11 is 77. And 7 and 3 is 10. Carry the 1, and that works out. Bring down the 0. 11 into 30. Look at that. We did 11 into 30 already. We know it's going to come out 2. 2 times 11 is 22. If I subtract here, I get an 8. 8 and 2 is 10. Carry the 1 to the bottom and bring down another 0. So 11 into 80. Well, we did 11 into 80 before, and it came out 7. And so 11 times 7 is 77. So do you see that everything we're doing here, from this point on, we had 30 here and we have 30 here. We have 80 here, we had 80 here. Okay? And we're going to get the same cycle of results. We're going to go from 30, and then 80, and then 30, and then 80, and then 30, and then 80. And so the digits in the answer are going to be 0.27, and then 27, and then another 27. So here we're going to get repeating digits. We have a repeating block. You're probably most familiar with numbers like 1/3, where the answer just comes out 0.33333, but here you have a repeating block that's 2 digits long, 0.27, 27, 27, and so forth. You can get all kinds of different lengths of repeating blocks. This kind of a decimal is called an infinitely repeating decimal. Okay, so we have these two kinds of decimals that we know we can get from a fraction. It turns out there's a way to get each of these kinds of decimals back into fractions. Okay, just a word. If you have a decimal which is not a terminating decimal, and it's not a repeating decimal where you have a regular repeating block like this, it turns out you can't convert them into fractions. Those are called irrational numbers, and it's something that you'll get to later in your math. So let's learn to convert the kinds that we can convert. Okay, let's see if we can go backwards. A minute ago we got 0.375 from a fraction. Let's take this and try and convert it back into a fraction. The trick is simply read the number. This is tenths, hundredths, and thousandths. And so if you read the number, you would say this is 375 thousandths. If I listen to what I just said and write it as a fraction, 375 thousandths, this is a fraction that's equivalent to that decimal. Now, from here, we might be able to reduce. And in fact, notice this ends in a 5, this ends in a 0. We know both of these are divisible by 5, so let's look at that. Take 375, if I divide it by 5, 5 times 7 is 35. Subtract, I get 2, bring down the 5. 5 into 25 goes 5 times. So if I divide this by 5, I get 75. If I divide 1,000 by 5, 5 goes into 10 twice. And I think you can see it's just going to be even. 200. Okay, so this will be 200. Okay. Notice that 75 is 3 times 25. And if I take 25 times 4, I get 100. So 25 times 8 would be 200. So dividing both of these by 25, I get 3 here and I get 8 here. And so we have 3/8. And that's where we got the 0.375 in the first place. But we could do this for any number, whether we know the fraction it comes from or not, as long as it's a terminating decimal. So for instance, 0.17, okay, tenths and hundredths, so that's 17 hundredths. That won't reduce, but we're done. How about 0.8? Well, that's 8 tenths, so you write 8 tenths. Now that'll reduce. These are both even. Half of 8 is 4, half of 10 is 5, so that's equal to 4/5. What if we have a repeating decimal, an infinitely repeating decimal? And we saw one example a minute ago, 0.27272727, and so forth, okay? This requires a little more sophisticated trick, and some of you may be able to follow what I'm about to go through, and some of you may not. It depends on where you are in your education at this point. So if you're getting close to algebra, you're getting close to maybe seeing this kind of thing. So I'm going to use algebra actually, but it's very simple algebra, and I'll explain it as I go. So I'm going to teach you a little algebra enough to do this problem. So here's a number, and I want to find what is this number in a different form. So let's give this number a name. I'm going to call it n. Okay, so if this number is n, anytime I talk about n, that's the number I have in mind. Okay. Now, notice that this number has this interesting property that it keeps repeating every 2 digits. So what if I took this number and multiplied it by 10 and times 10 again? So in other words, move it 2 decimals over. So instead of 0.272727, if I move the decimal 2 places, it would be 27.272727. Let's write that down. 27.272727. And it's going to keep on going because this was an infinite chain, and so is that. But everything down that chain is going to match. This number is not n. I multiplied it by 100. Okay? So if this number we're going to call n, by moving the decimal 2 places, that's multiplying it by 100. And so that's 100n. Okay? Now watch. Here's where things get nice. What happens if I subtract? Notice that all of these digits which match up, when I subtract, they're going to all go away. All that's left is 27 on the right. What happens if I subtract on the left? What's 100 of something minus 1 of that same thing? 100 of them minus 1 of them. That's going to be 99 of them. And so I now have an equation that says 99n is equal to 27. So if n was this number and 100n is this number, the 99n is this number because I subtracted 100 of them minus 1 of them, 27 point all of this minus point all of this without the 27. All I have here is 27, here's 99n. Now, there's a thing you can do in algebra which says if you have an equation, so what's on the left is equal to what's on the right, I should be able to go through and multiply both sides by the same number, or divide both sides by the same number, and the equation will still be true. It's sort of like balance pans. Remember those old-fashioned kind of balance pans like this? And you put something here and you put something here, and if they balance, it means that they're equal weight. And so if I multiply this by something and multiply this by the same amount, I'm changing the weights on both sides equally. It should still be balanced. And if I divide both sides by the same number, same thing is true. It should still be balanced. Okay? Look at this equation here. This is equal to this. It's like a balance pan. What if I divided both sides by 99? Notice that the 99 will cancel. This is like a fraction. The 99 cancels, and all I have left is n. On the right I have 27/99. Will that reduce? I have it as a fraction now. In a sense, I'm done. Well, let's see if that will reduce. Notice that 27, if I add the digits, it comes out to 9. That's a clue that this is a multiple of 9. Other than the fact that you should know that this is 3 times 9. And this is a multiple of 9. This is 11 times 9. So if I divide top and bottom by 9, this becomes 3, and this becomes 11. And that's where we started, so we know we got it right. Okay. Let's take another example that's similar but not quite the same. What if I have a number that's 0.77777 and so forth? You know what 0.33333 is. That's a third. 0.66666 is 2/3, but you probably don't know what 0.77777 is. In fact, I don't know either. I just wrote that down, and I haven't stopped to work this out ahead of time. Well, let's call this n, just like we did before. But this time, notice that it only takes multiplying by 10 to move the decimal one full repetition block. So if in other words, the block that's repeating is only a single digit. And if I move the decimal by one place, I'll have a pattern that matches this. Moving it one place is like multiplying it by 10. So 10 times n is going to be 7.77777, and so forth. Again, we subtract, and notice all of the decimal part of this disappears, and what we have left is simply 7 on the right-hand side. Over here I have 10n minus n. In other words, 10 of them minus 1 of them is 9 of them. So 9n equals 7. Let's divide both sides by 9, and that gives us n equals 7/9. Okay, so here again we were able to take an infinite repeating decimal, and by applying the same kind of technique as before, except this time the block was only 1 digit long, we're able to recover it in the form of a fraction. Okay? So we can convert terminating decimals and repeating decimals into fractions. They take 2 separate techniques. Here you read the number, listen to what you read, and write it down as a fraction and reduce it. Here you have to use the trick we learned, assign a name to the number. Then if I move the decimal a certain number of places, that's equivalent to multiplying by 10 a certain number of times. And then you set up an equation that you have to solve, and you can come up with a fraction that way. Okay, those are the 2 techniques. This one definitely should know how to do. This one was a bit of a stretch, but maybe you're ready for it, maybe not. So if you didn't follow this one entirely, please recognize that I recognize that you may or may not be ready for this level of math, okay? But this was a tiny bit of algebra we used here. So that's something to look forward to. Algebra is going to let you solve problems that you would find hard to solve otherwise. Okay, enough for now.